Welcome. Let's discuss a very specific example of the remainder theorem. So let's consider the question, is 3x minus 1, can that be a factor of the expression 9x cubed plus 15x squared minus 9x plus 1? When we take a look at the expression, that we want to know if it's a factor or not, notice that the highest degree, it is 1, which is good. That is needed to use the remainder theorem. But there's a slight problem. The leading coefficient, it's not of a value of 1, but it is of a value of 3. So that's a problem. Now we need to fix that problem. And one strategy that we can do is to rewrite our factor. Let's get the factor that we were given, 3x minus 1, and let's set it equal to 0. Let's start by adding 1 to leave the x by itself. Then we're going to get 3x is equivalent 1, and now let's divide it by 3. X is equivalent to 1/3. So therefore, the factor that we are going to consider, it's x minus 1/3. Now, how are we getting this factor? Just real quick. Well, if we have x is equivalent to 1/3, what we can do, we can subtract 1/3 to the left and the right. This cancels out, then we get x minus 1/3 is equivalent to 0. That's how we are considering this factor. And now that we have our new factor, now we can apply the remainder theorem. Let's evaluate by the value of the opposite of the factor that we are considering, which in this case is positive 1/3. Let's get our initial polynomial, and every time we see a value of x, let's evaluate it with 1/3. So we're going to get 9 times 1/3 raised to the third plus 15 times 1/3 raised to the second minus 9 times 1/3 plus 1. So here we're going to obtain 9 times 1/27 plus 15 times 1/9 minus 9/3 plus 1. And when we combine all this, we get a result of 0. So we can come up with a conclusion. Because our remainder is equivalent to 0, then we can say that 3x minus 1 is a factor of the expression 9x cubed plus 15x squared minus 9x plus 1. And we obtain the result by using the remainder theorem. Hello. If you would like to continue learning about mathematics, you can check out the videos on the left.